Hi guys, myself from English Dishes and the problem on LeetCode. Subsets. So you're given an integer array numbers of unique elements, return all the possible subsets. That is the power set. Subsets are nothing but power set. So how do we find a power set for a given set? So the solution set must not contain duplicate subset and return the solution in any order. So subsets means if the given, let's say the set is 1, 2, it contains only two elements and it must be unique. That's it. It's a array consisting of unique elements. So what are all the subsets of this? One will be an empty set, other with the single element will check, that is 1, then 2. Then other possible case will be two elements, that is 1, 2. So this is the only subset possible, and you cannot have 2, 1. No, that is not the case. That will be a duplicate subset. So only the unique elements in any order they might. And total there are four subsets for this array. So we know that for subsets we count. How do we count that? So if there is a single array, then it will be of two subsets. One is empty and there is one. So it's nothing but 2 power the number of elements in the subsets. So if number of elements is 1, then 2. If number of elements is 2, then 2 power 2 will be 4. Similarly, if the number of elements is 3, let's say 1, 2, 3, then the total number of subsets will be 8. That is 2 power 3. So let's take this example and find all the subsets of this. I'll just say this is here. So now we'll take the example 1, 2, 3. So what are the subsets? One with an empty set, fine. Next comes with a single element, that would be 1. Array with 1, array with only containing 2, array with only containing 3. So combination of two elements we have to take now. So that will be 1, 2, then 2, 3, then 1, 3. Done. Combination of two elements, all the subsets are done. Then combination with three elements, that is only one set, that is 1, 2, 3. So you can find the count now. 1, 2, 3, 4, 5, 6, 7, 8. Total of 8 subsets we have found. That is nothing but 2 power 3. So if you need to mention how do we solve this problem, we can use recursion, but we will use bit manipulation method here. So using bit manipulation, how do we solve this problem? We will see. So 1 to 3, right? Now I'll represent, since there are 8 subsets, so I'll represent 0 to 7. 0, 1, 2, 3. Okay, 0 to 8, since there are 8 subsets, so 0 to 7, because we are starting from 0 till 7 is enough. So 1, 2, 3, 4, 5, 6, 7, 8. 8 subsets we are representing by 0, 0, 0, 0, 0, 1, the number, corresponding number in the binary format. So the simple way to write this is first put 4 zeros, 4 ones, then 2 zeros, 2 ones, 2 0, 2 1, then 0 1 0 1 0 1 0 1. So this is the easiest way to write the table. And we'll give the indexing here. This is 0th indexing, first indexing, second indexing. I mean the each element in the array. Now what we need to do? So we need to find. So this represents 0, 1, 2, 3, 4, 5, 6, 7, 8. So we have all the subsets. So what does this 0 indicate? This bit is not set. So we'll not take 1 into consideration. Is 0 is set into 1? No. 0 is not set into 1. So none of them is taken into consideration. So this will be an empty set. Next come to this one. So here first bit is set to 1. That means 1 is taken. Other two bits are not taken. So this is subset with element containing 1. These two are done. Next move here. Here in this case middle position is taken as a set bit is taken, so 2 is taken into case, so subset with element containing 2. Here if you see 0 and first bit are set, so that means 1 comma 2 are considered, 3 is not set, so 3 is not considered, so 1 comma 2, this is a subset, so 1 comma 2. Here you could say last element, that will be 3, so 3 also done. Then here first and last means 1 comma 3, so 1 comma 3 is done. Then this is the second and third, so 2 comma 3, 2 comma 3, and at last all are set, so set bits, so 1 comma 2 comma 3. Hence, you could see we have represented all the subsets in the form of binary format. So we need to decode this now. And for that, we have to run the loop I equal to 0 to less than 2 power 3, right? Till 7 we have to take 0 to 7. So how do we take 2 power 3 in the binary format? So for that we know. So if we need to check whether a bit is set or not, for example, let's take 0, 1, 0. So we need to check here this second bit is set or not. How do we check the second bit is set or not? So for that we have to do the left shift of 1 by 2 positions. Here it's 1 position. Okay. So if we do left shift of 1 by 1 position, what it will give you? Left shift of 1 by 0 position means it's 1. So left shift of 1 by 1 position means it will give you 1 position left shifted. So 1 0. So if you do AND with 1 0 now, since it's the second position, it will tell you whether the bit is set or not at this position. Similarly, if it is 1 0, 1 1 0, or we will take other example. Okay, 1 1, okay, 1 1 0, yeah. So in this case, we have to check for the third position whether it's set or not. So in this case, left shift 1 by 2 positions, that will give you 100. So AND with 100. So what will be 0 0 0, 1 0 0, 1 1 1. So it's saying the third bit is set here. So if this returns 1, then you can add this particular element to the subset. So similarly here also 2 power 3 means we have to left shift by 3 positions. So 1 will be left shifted by n positions, n minus 1. Otherwise what we can do, if we are giving equal to condition, then this will be n minus 1. What if it is lesser than condition we are giving? I lesser than 8 means n left shift by n positions we have to do. So 1 left shift by n positions. So this will give you 1 0 0. So that is nothing but. So yeah, here it will be 1 0 0, which is nothing but 2 power 0, 2 power 1, 2 power 2, 2 power 0, 2 power 1, 2 power 2, 2 power 3. This is 8. So we'll take only this I lesser than 8. This will be taken but in the binary format. So okay. So I equal to 0 to 2 power 3. 2 power 3 how we do? 1 left shift by n positions. Then you have to go inside the loop. Now you have to create a subset one. So we'll create a list in Java or C++ vector we will use. So list empty list we will have. Here also list inside the list because the resultant contains a list inside the list. So you could see vector inside the vector. So this list, whatever you get the subset, you add that to the list. Here also list inside the list you will have. So you add this list over here. So list will be created. Then again for loop we have to 0 1 2 indexing. So for j equal to 0 to n minus 1 or lesser than n. Anything is okay. So I'll give lesser than n minus 1. So 0 1 2 indexing we have to consider, right? So that's why. So each bit we have to check whether it's set or not. If it is set, then we have to take the corresponding element from the array. So j equal to 0 to n minus 1. So we iterate from 0 to 7. So each time here we have to check for each bit whether it's a set or not. So how do we check whether it's a set bit or not? So for that I, the number, whatever you have, if it is 4 4 and with the position. So if you need to check this position, then 2, or this position, then 1, this position 0. So for that, finding that position, we have to make one left shift by j positions. So once you do that, you have to check whether this is only one and Yeah. So to check whether it's not equal to 0. If it is equal to 0, then it's not set. If it is not equal to 0, then it's set. So you cannot give equal to 1. Why? Because, so if I take this example now, I have to check in this position. Okay. So 6, you have to AND with 1 0. If you do left check by one position for j equal to 1, no? So that will give you 1 0. So 6 AND with 1. 6, how do you represent? 2 power 0, 2 power 1, 2 power 2. So this will be 4 and 2. So 1 1 0, 1 0. So 0, 1 and 1 will be 1. 1 and 0 will be 0. This is giving you 1 0. 1 0 means it is 2. It's not 1. So you cannot give equal to 1, whether it's set or not. We are checking the number here, integer number. If it is equal to 0, then it's set. So it should not be equal to 0. Then what we need, we have to add that to the list. So list dot add or pushback in Java, C++, this particular element. So that is nums of j. So first position this will be present, you add that. So instead of 0 1 1 2 here, 0 1 2 also can be. That is okay. You will result end up with the all the subsets. So after this loop, you will have entire. If this was the case, you will have 2 comma 3 in the subset. You have to add this subset to the list. So again, this list dot add of this list. Which list? 2 comma 3 will be added to the subset entire resultant list. So that is the code. So we'll write this. So vector int, we'll name it as result. So next int n equal to nums dot size. So once you have this, so for int I equal to 0, I lesser than 1 left shift by n positions, then I plus plus. We'll create a list once first. So vector int, name it as subset. Now for int j equal to 0 till j lesser than n, so 0 1 2, all the three indexing, then j plus plus. We have to check here if I and with 1 left shift by how many positions? J positions. If it is not equal to 0, then we have to add that to the subset. So subset dot pushback of nums of j. So after this, we have to add the entire subset to the result. So result dot pushback of subset. So at last, return the result. Here, okay. Yeah. So for Java also same thing. So here syntax is different, and here add, then instead of size it's a length. Yeah, list integer. So list inside the list, and you create a subset. So we'll submit this as well. Okay, successfully submitted. If you understood the concept, please do like the video and subscribe to our channel. We'll come up in another next session. Until then, keep learning. Thank you.